Welcome back to our Spring Boot tutorial series. Today, we're diving into an exciting topic: how to write our own custom message converter for requests and responses. Custom message converters give us the flexibility to handle different data formats and tailor the way our API processes incoming and outgoing data. Ready to enhance your Spring Boot skills and take control of your data flow? Let's get started. Up until now, we've been building APIs where we send requests and receive responses as objects. You might have noticed that when we send a JSON request through Postman and get a JSON response back, our objects seamlessly convert to and from JSON. Have you ever wondered how this magic happens? Spring Boot handles this conversion for us effortlessly. But how exactly does it do this? It uses something called message converters to transform our JSON data into Java objects and vice versa. This allows us to work with our data in a way that's natural and convenient, without worrying about the underlying format. Today, we're going to pull back the curtain and explore how Spring Boot's message converters work. We'll learn how they automatically map JSON to Java objects and how we can create our own custom message converters to handle other data formats or special cases. Ready to dive deep into the magic of data conversion in Spring Boot? Let's get started. Alright, let's uncover the magic behind Spring Boot's data conversion. First, let's open the HttpMessageConverter interface class. This powerful interface is the backbone of how Spring Boot transforms JSON/XML data into Java objects and back again. Take a look at the screen. On the left side, you can see Spring Boot's converter package filled with different converters for JSON, XML, and more. These converters are the magic workers behind the scenes, turning our data into Java objects and back again. Spring Boot comes with several powerful out-of-the-box converters, like the mapping Jackson2 HTTP message converter for JSON and the JAXP2 root element HTTP message converter for XML. These converters ensure that our requests and responses are seamlessly transformed, allowing us to work with data naturally. Alright, let's dive into the methods within the HTTP message converter interface and see how they work their magic. First up, we have the canRead method. The canRead method is like a gatekeeper for your data. It takes two inputs: the class you want to convert to, and the media type of the incoming data. This method checks if the converter can read and transform the incoming data into the specified class. Imagine your API receives a request with data in JSON format, and you want to convert it into a user object. The canRead method checks if our message converter supports JSON media type and can map it to the user class. If it can, it returns true, signaling that this converter is ready to handle the data. This method is crucial because it ensures that our converter only kicks in when it can actually do the job. Next up, let's talk about the canWrite method within the HTTP message converter interface. The canWrite method is like the flip side of canRead. While canRead checks if the converter can handle incoming data, canWrite determines if the converter can handle outgoing data. It takes two inputs: the class of the object you want to write and the media type you want to convert it to. For example, suppose you have a user object and you want to convert it to JSON format for the response. The canWrite method checks if our message converter supports converting the user class to the JSON media type. If it does, it returns true, indicating that this converter can handle the data conversion. Understanding canWrite is essential for knowing when your custom converter will be used to transform Java objects into the desired media format for responses. Next, let's explore the getSupportedMediaTypes method within the HTTP message converter interface. The getSupportedMediaTypes method plays a crucial role in defining what media types your converter can handle. It returns a list of media type objects, each representing a type of data format that the converter supports. For instance, if your converter can handle both JSON and XML, getSupportedMediaTypes will return a list containing application/JSON and application/XML. This method helps Spring determine whether your converter is suitable for processing a given request or response based on its media type. Next up, let's delve into the read method within the HTTP message converter interface, which is called when canRead returns true. The read method is where the real magic happens. This method is responsible for reading the incoming data and converting it into a Java object. It takes two main inputs: the class you want to convert the data into, and the HTTP input message that contains the incoming data. For example, when your API receives a JSON payload, The read method will parse this JSON data and map it to the corresponding fields in a Java object, such as a user class. Here's a quick rundown of what happens inside the read method. It reads the raw data from the HTTP input message. It processes this data according to the specified media type, like JSON or XML. It converts the processed data into an instance of the specified Java class. The read method is invoked when canRead returns true, indicating that the converter can handle the incoming data. Next up, let's explore the write method within the HTTP message converter interface. The write method is the counterpart to the read method and is responsible for converting a Java object into an outgoing data format. It takes three main inputs: the object to be converted, the media type for the desired output format, and the HTTP output message that will contain the converted data. For instance, if your API needs to send a user object as a JSON response, the write method will take the user object as input, convert this object into JSON format based on the specified media type, write the JSON data into the HTTP output message, which is then sent back as the response. Here's a breakdown of the write method. It takes the Java object you want to send. It processes this object according to the specified media type, like JSON or XML. It converts the object into the appropriate format and writes it to the HTTP output message. The write method is crucial for ensuring that your API responses are correctly formatted and ready to be sent to the client. It's called when canWrite returns true, indicating that the converter can handle the outgoing data. Alright, let's take our Spring Boot skills to the next level by designing our very own custom message converter. To see it in action, we'll create a new controller that accepts a custom object in the request and returns the same custom object in the response. First, let's create our custom class. This class will have three fields: int1 of type int, float1 of type float, and str1 of type string. Use Lombok for generating getters, setters, a no-args constructor, an all-args constructor, and a builder pattern. Great! Our custom class is ready. Now, let's create a new class called Custom Controller. In this controller, we'll expose a post API that takes a custom object in the request body and returns the same object. Fantastic! Our custom controller is ready. Now, it's time to design our very own custom message converter. Let's create a new class called Custom Message Converter. This class will handle the conversion of our custom objects and implement HTTP message converter and override all required method. Alright, let's dive into the implementation of our custom message converter. The first method we need to override is canRead. As we discussed earlier, this method returns true when the converter can read and convert the incoming request data. For our custom converter, we'll support reading only if the request object type is custom and the media type is application/JSON. This ensures that our converter only handles the specific scenarios we intend it to. Additionally, we'll add some logging to verify that this method is being called correctly. In the canRead method, we have checked two key conditions. First, we verified if the class is assignable to custom. Second, we checked if the media type includes application/JSON. Since both conditions are met, we return true, indicating that our converter can handle the incoming request. Added some logging to confirm that our method is being called correctly. Next up, we have the canWrite method. Just like with canRead, we'll ensure that our custom converter only handles writing for custom objects and application/JSON media type. To keep things simple, we'll copy the code from our canRead method, as the logic will be very similar. Next, we have the getSupportedMediaTypes method. This method is responsible for returning the media types that our converter supports. For our custom message converter, we will only support application/JSON. So, we'll set this method to return a list containing just application/JSON. Next up, we have the read method, where the real magic happens. First, let's add a log statement to make sure we know when this method is being called. You'll notice that the second parameter is HTTP input message. This contains an input stream, which holds the JSON data we sent in our request. Think of this input stream as a direct pipeline to the raw JSON data. Our job now is to read from this input stream, convert the JSON data into a custom object, and return it. To make this happen, we'll use the powerful object mapper from the Jackson library. The object mapper has a read value method that takes an input stream and the class type we want to convert to. Use this method to transform the JSON data into our custom object effortlessly. Now, let's move on to the write method, where we'll handle the outgoing data conversion. In the write method, you'll notice a few key parameters. The first parameter is the custom object, which contains the data we need to return from our API. The second parameter is media type, which corresponds to the value we send in the accept header from Postman. The third parameter is HTTP output message, which contains the headers and an output stream. First, we'll add a log statement to confirm that this method is being called. This helps us verify its execution. Here's what we need to do. Set the content type in the HTTP output message headers to match the media type we received. This ensures the correct content type is present in the response headers. Use the output stream from the HTTP output message to write our custom object as JSON. To convert our custom object to JSON and write it to the output stream, we'll use the object mapper's writeValue method. This method takes the output stream and the object to convert, and it handles the conversion for us. Now, our custom message converter is ready to go. But we need to let Spring know about our new converter so it can actually use it. To do this, we'll need to register our custom converter within our Spring Boot configuration. This way, Spring will recognize and utilize our custom message converter alongside its built-in converters. Alright, let's create a new class called WebConfig to register our custom message converter. By creating this configuration class, we can tell Spring Boot to recognize and use our custom message converter. First, let's annotate our class with @configuration. This tells Spring Boot that this is a configuration class. Next, we'll implement the WebMVC configurer interface. This interface allows us to customize Spring MVC's configuration. Now, let's override the configureMessageConverters method. This method gives us a list of HttpMessageConverters that we can add to. Here's the important part. This list already contains Spring's built-in converters. If we add our converter at the end, it might never get called because Spring's converters will handle the data first. To make sure our custom message converter gets used, we'll add it at index 0. This way, our custom converter will be picked up first, before any of the built-in ones. And just like that, we've integrated our custom converter into Spring Boot. By placing it at index 0, we ensure our custom message converter gets priority. Let's start the application. Our application is up and running. Now, let's switch over to Postman and test our setup. We've created our custom API with the URL /custom. And it's designed to handle custom objects with int1, float1, and str1 variables. Now, let's test it out by sending this data in JSON format using Postman. Select the post method. Enter the URL localhost 8080/custom. Click on the body tab, select raw, and choose JSON from the drop-down menu. In the body, add a JSON object with int1, float1, and str1. Hit the send button to send the request. Take a look at the response. As you can see, the data we sent in the request is exactly what we received back in the response. We set up our API to return the same object we sent, and it's doing just that. Now, let's switch over to IntelliJ and verify our setup by checking the console logs. Open the console logs and take a look. You can see that the canRead method was called first, confirming that our converter can handle the incoming data. Right after that, the read method was triggered, successfully converting the JSON data into a custom object. Next, the canWrite method kicked in, returning true, which indicated that our converter could handle the outgoing data. Finally, the write method was called, converting our custom object back to JSON and sending it in the response. Seeing these log entries in sequence verifies that our custom message converter is working seamlessly, managing both the reading and writing processes as intended. Looking at the logs, I noticed something interesting. Instead of printing application/JSON, it's only showing application. This happened because we only printed the type. Let's fix that by changing our log statement to use to string, so we get the full media type displayed correctly in the logs. Now, let's restart the application. Hit our endpoint again in Postman. Open the console to check the logs. This time, we should see the correct media type, application/JSON, along with the char set, printed in full. You can now see that the media type we set in the write method is correctly shown in the response headers in Postman under content type. Our message converter is working perfectly. You can see that the media type we set in the write method is correctly reflected in the response headers in Postman under content type. This confirms that our custom message converter is successfully managing media types and processing requests and responses as we designed. Great job, everyone! Everything is functioning just as we planned. To summarize, we've successfully created and registered a custom message converter in Spring Boot. We saw how it handles reading and writing JSON data for our custom object, and verified that it works seamlessly through console logs and Postman responses. Thank you for joining me in this session. If you found this video helpful, please subscribe and hit the notification bell so you never miss an update. See you next time.